So now these are some more derivative applications. So for this first one, given f of x equals cos squared x, find all relative extrema. So for this, you're going to have to find the first derivative. So f prime of x equals 2 cos x times derivative of cos x, which is negative sine x. Now we're going to set that equal to 0. Now that's going to equal 0 when cos is pi over 2 and sine of x at 0 and pi. So now we can plot those on number line. Pi over 2, 0, pi. So now here, this is in quadrant 1. Both sine and cos are positive, times the negative will be negative. Now here, this is quadrant 2, where sine will be positive, cos will be negative, times the negative, which will be positive. So we see this is going to go from negative to positive, so it's in R min, and it's going to happen at next value of pi over 2, and the other coordinate we're going to have to plug in to find it. So cos squared of pi over 2, that's just going to be 0, because cos of pi over 2 is 0, square is still 0. So it's at pi over 2 comma 0. That's your R min. And that's your only relative extrema. For the next problem, given the position of a particle is s of t equals 8 sine 2t, when is the particle moving right on the interval from 0 to pi over 2? So for this one, we're going to have to find the first derivative. So v of t equals 8 times derivative sine is cos 2t times 2. So now we're going to set that equal to 0. So 16 cos 2t equals 0. So now that's going to equal 0 when you get the cos of pi over 2. So 2t has to equal pi over 2. So t equals pi over 4. So now we can plot that on the number line. Goes from 0 to pi over 2. So now this would get you values in the first quadrant, which are positive. That's positive. And this would get you values in the second quadrant, which are going to be negative for cos. So when the particle is moving right is when it's positive. So that would be from 0 to pi over 4.